Let us continue for the next example. 2s squared minus 3s plus 2 divide with s plus 2 multiply with the s squared plus with 4. So we have something multiply something at the denominator, so you have to solve by using rational function. 2, this one is a linear term. S squared plus 4, this one is a quadratic term. So for the quadratic term, so you have to check whether you can factorize or not. So how to check whether you can factorize or not? By using the calculator. Mod EQN degree. So we will choose degree of 2 because the highest power is power of 2. So when you key in the value in the calculator, calculator will give you the answer in terms of 2i and negative 2i. Means that this is the complex root. Complex root means that the quadratic term cannot be factorized. So now proceed for the next step. Write in the terms of the partial fraction. So now, how to write our terms in the partial fraction? S plus 2 is a linear term. So this one will become A over S plus 2. For the second bracket, S squared plus 4 is a quadratic term that we cannot factorize. So this one will become plus BS plus C divide with S squared plus with 4. So now we have to find the value for the constant A, B and C. So you have to eliminate the denominator at the bottom side. So next step, eliminate the denominator because we want to find what is the value for the constant A, B and C. So create an equation by eliminate the denominator. So the left hand side, we will copy everything at the upper side. 2s squared minus 3s plus 2 is equal to A is divided with s plus 2. So by refer to the left hand side, we will close s plus 2, means that s squared plus 4 will be multiplied with A. So A multiply with the s squared plus with 4 plus BS plus C, make it everything in the bracket. BS plus C is divided with the s squared plus 4. So we will close s squared plus 4. S plus 2 will be multiplied with the BS plus C. So for the previous example, we find the constant for the A and B by let any suitable value of S in the bracket, so that one will become 0. But for this example, the easiest way is by expanding everything on the right hand side and then we will compare the coefficient. Okay, so I will use that method for this example. Find value A, B and C by expand terms in the right hand side and then compare the coefficient. So for the left hand side, there is nothing that you have to expand, so we just copy down everything that you have on the left hand side. 2s squared minus 3s plus 2 is equal to A multiply with the s squared multiply with the 4. So as squared plus 4a plus bs plus c multiply with the s plus 2. So bs multiply with the s will become bs squared. Bs multiply with the 2 will become 2bs. C multiply with the s will become cs. C multiply with the 2 will become 2c. So now we want to compare the coefficient. Compare the coefficient means that you have to refer to the highest power of s that we have. So the highest power that we have is s power 2, s power 1, s power 0. So start from the left hand side. S with the power of 2, we have 2. 2 is equal to s with the power of 2. On the right hand side, we have a plus with b. So a plus with b. So this is our first equation. So now compare for the s power 1. On the left hand side, we have negative 3. Negative 3 is equal to s power 1. On the right hand side, we have positive 2b plus c. 2b plus with c. So this is our second equation. So now compare for the s power 0, means that there is no s beside the number. On the left hand side, we have 2. On the right hand side, 4a plus 2c. 4a plus 2c. So this is our third equation. So now you have to solve everything here by using calculator. So how to solve by using calculator? So you go for the mode, EQN, unknown. So unknown means that you have how many variable or how many constant that you want to solve. So you have 3 constant, which is constant A, constant B, and constant C. So for the unknown here, we will choose 3 unknown. So the calculator will ask you to key in the value for the A1, B1, C1. So A1, B1, C1 refer for the first equation. So A1 means that what is the value beside the constant A. So A1 is 1. B1, what is the value for the constant B, which is 1. C1, what is the value for the constant C. So there is no C here, means that the number is 0. And there is another one, which is D1. D1 is the value whereby you have on the left hand side. So D1 is equal to 2. So repeat the process until you key in for the equation 2 and equation 3. So after you have finished key in all the equation, the calculator will give you the answer x is equal to 2, y is equal to 0, z is equal to negative 3. X is equal to 2 means that our A is equal to 2. So this is our A is equal to 2. Y equal to 0 means that B is equal to 0. Z is equal to negative 3 means that our C is equal to negative 3. So now you have to substitute all the constant A, B, C into the partial fraction. So this is our previous partial fraction. So you have to substitute A become 2, B become 0, and C become negative 3. So therefore, 2s squared minus 3s plus 2 divide with s plus 2, s squared plus 4 is equal to A will become 2 over s plus 2 plus B will become 0s minus 3 divide with s squared plus with 4. So now we want to solve for the inverse Laplace transform. So in order to solve for the inverse Laplace transform, write the notation for the inverse Laplace transform for every single term that you have. Okay, so if you have a constant, then you have to bring the constant to the outside. So for the first curly bracket here, you have 2 at the upper side. So bring constant 2 to the front. 2 Laplace inverse 1 over s plus 2. For the second curly bracket, we have 0s minus with 3. So 0s means that there is nothing here because 0 multiply s will become 0. So we only have consider negative 3. Bring negative 3 to the front. So the constant negative 3 Laplace inverse 1 over s square plus with 4. So now you have to refer to the table of the Laplace transform, for which part you have Laplace inverse, a constant at the upper side, and you have s with the power of 1 at the bottom side. The second curly bracket, you have to refer whereby you have a constant at the upper side, and you have a s square plus a number at the behind. So by refer to the table, Laplace inverse 1 over s plus 2, the suitable one is 1 over s minus a, whereby the answer will become exponent at. For the second curly bracket, Laplace inverse 1 over s square plus 4, the suitable one is a over s square plus a square, whereby the answer will become sine of at. So for here, s plus 2, our a is equal to negative 2. So for second curly bracket, s square plus a square is equal to 4. So a is equal to 2. So Laplace inverse 1 over s plus 2, whereby a is equal to negative 2, the answer will become exponent negative 2t. 2 exponent negative 2t minus 3. Laplace inverse 1 over s square plus 4. So you have to write in terms of a at the upper side. So this one must be written as a equal to 2. Laplace inverse 2 over s square plus 4. So when we write 2 at the upper side, you have to divide with 2 at the front. So now simplify the answer. 2 exponent negative 2t, negative 3 over 2 will become negative 3 over 2. Laplace inverse 2 over s square plus 4 will become sine of at. Sine of 2t. So this is the final answer for the example B.